Okay, here's a lesson for section 1.2, substitution. The objective of this lesson is to be able to solve a linear system using the method of substitution. Okay, we have to remember that a linear system is when we consider two or more linear equations at the same time. So, for example, if I had these two equations, I consider them at the same time, that is a linear system. Okay. We also have to remember that to solve a linear system means to find the point of intersection. So, I've got two lines. If I solve the linear system, that means to find that point of intersection, that xy coordinate where those two lines intersect. Okay. Today what we're learning is the method of substitution, solving a linear system by substituting for one variable from one equation into the other equation. And I'll show you how that works in just a little bit, okay? Up until now, the first lesson of this unit, we learned how to solve a linear system by graphing, okay? So I'd have a graph here. I had two lines. Let's say I had the equations for those lines, and that's what their graphs looked like, okay? I would then look at the graph and find the point of intersection right here, okay? I would then look at the coordinate and approximate what it is. It looks like that's at about -1 on the x-axis, and it looks like it's at about 1.5 on the y-axis, okay? But how do I know for sure that it's at -1, 1.5 by looking at that graph? That could be at 1.51. That could be at 1.6. It could be at 1.45 on the y-scale, okay? I can't tell for sure by looking at a graph, so it's just an approximate value there. What we're going to learn today is substitution, okay? Substitution, which is an algebraic method which will give us an exact point of intersection, okay? So let's go ahead and do an example of substitution. Here's the steps here. I'll just read them over quickly, and then I'll reference them while I do an example, okay? So substitution. First step, isolate a variable in one of the equations. Either one, choose any variable, that x, that y, that x, or that y, get it by itself, okay, isolate it. Choose the easiest one, and I'll talk to you about that in a minute. You then substitute the expression that you've isolated into the second equation. So if I isolated this x, I would then substitute whatever that x is equal to into the other equation for x, okay. I then combine like terms and solve for the variable, okay? There will then only be, after we have substituted into the second equation, there will only be one variable left to solve for. We'll solve for that, okay? After you've solved for that, you then substitute that value into one of the original equations and solve for the second variable. You'll then have solutions for both variables. That will give you the coordinates of the point of intersection, okay? Let's do an example and you'll see what that looks like. Okay, so I have my two equations. My first equation is x plus y equals 5. Let me try and write that again. X plus y equals 5. And I have my second equation, 3x minus y equals 7. Okay, first step, isolate a variable. Choose any variable and isolate it. I'm going to choose this x to isolate right here, okay? It's going to be nice and easy to isolate that variable, and I'll show you how. To get that x by itself, all I have to do is move that y to the other side of the equation, okay? So I now have x equals 5 minus y. Y was positive on the left. When I move it to the right, it becomes negative, so x equals 5 minus y. X is now isolated. Isolated means by itself on one side of the equation, okay? And keep in mind it has to be positive when it's isolated, okay? So I couldn't have negative x isolated. I have to have positive x. So positive x is isolated. It's by itself. I know x is equal to 5 minus y, okay? I could have isolated any variable in either of the equations, but I'll show you why I didn't isolate. Let's say you said, why didn't you isolate this x right here? I'll show you why. Okay, you could, and you'll get the same answer, but it's going to be a lot more work. So if I wanted to isolate that x, I'd have to move the y to the other side. So I'd have 7 plus y. And then I would then, because I have 3 times x, I'd have to divide the 3 to the other side to get x by itself. So I'd have 7 over 3 plus y over 3. And you can see now I've got these fractions, okay? And that's going to make a lot more work for us, okay? Even though you'll get the same answer in the end, it's going to make it a lot more work, okay? So we're not going to isolate that. The trick to deciding what to isolate, you always want to isolate a variable that has a coefficient of 1 in front of it. Okay? This is a coefficient of 3 in front of the x. So we're going to get fractions when we divide that 3 out. Okay? Always choose a variable that has a 1 in front of it. And if you don't see a number in front of the variable, remember there's an invisible 1 there. So there's a 1 in front of here, there's a 1 in front of here, and there's a 1 in front of here. Okay? So don't forget that. Okay, so now we've isolated a variable in one of the equations. We've isolated the x. So remember, I'm trying to figure out where these two lines have the exact same values. So if I've determined that x equals 5 minus y in this equation, I then have to determine what value of y keeps this true when 5 minus y is subbed in for x in the second equation. Okay, so what I'm going to do, I'm going to substitute this expression, this 5 minus y, into the second equation for x. I've determined with the first equation, x is equal to 5 minus y. I then sub that 5 minus y in for x into the second equation, and then solve for y. Okay? So this is step number 2, substitute this expression into the second equation. So I'll just go ahead and do that. When you substitute, so I'm going to write that, sub x equals 5 minus y into equation 2. Okay? So when you plug in 5 minus y for x, put it in brackets. That way you remember to distribute the 3 to each term inside the brackets. Okay? Leave everything else the same, just replace an x with 5 minus y, because the first equation tells us that's what x is going to be equal to. And this method will help us determine where these are going to be the same, okay, where these lines are going to intersect, where the x and y coordinates are going to be equal to each other. Okay? So leave everything else the same, plug in 5 minus y in brackets, so I remember to now distribute this 3 to each term inside the brackets. Okay? That's the distributive property. Don't forget about that. So I now get 3 times 5 is 15, minus 3 times y is 3y, so minus 3y. Leave everything else the same for now. Now I'm going to collect my like terms. These are like terms here. Okay? Negative 3y and negative y. That gives me negative 4y. I'm going to move that 15 to the other side so I can collect it with my other constant. So 7 minus 15. I get 7 minus 15. Okay, I get negative 8. I'm going to divide the negative 4 to the other side. Negative 8 divided by negative 4 gives me 2. So what my y value is 2. Okay, so I know where these two lines intersect is at 2 on the y scale. Okay, so now to determine what the x coordinate of their point of intersection is, I now substitute this 2 into either of the original equations. I could substitute it in for that y, or I can substitute it in for that y, either one, because it should give me the same answer, because at y equals 2, okay, so let's say this is our y scale here. So if this is y equals 2, okay, the x coordinate is going to be the same for both of those lines at that point, because this is where they intersect. Okay, so I should be able to plug this 2 into either equation for y, and it'll give me the point of intersection, the x coordinate of the point of intersection. Okay, because those two lines should have the exact same x coordinate at y equals 2. Okay, so let's go ahead and do that. So I've solved for the variable. I'm now doing step 5, substitute this into either of the original equations. I'll sub it into the first one. It looks like easier numbers. So x plus y equals 5. So I'll just write down what I'm doing again. So sub y equals 2. I'm going to sub it into equation 1. You could have subbed this one into either 1 or 2, but I'm going to sub it into the first equation, which is x plus y equals 5, I think. X plus y equals 5. Good. So now, plug in y equals 2. So x plus y is equal to 2 equals 5. Solve for x. Move the 2 to the other side. 5 minus 2 will give me 3. That means my point of intersection, I now have the x and y coordinate. Point of intersection is 3, 2. Okay? Remember, a coordinate is written as an x, y coordinate. So 3, 2. Okay? So that's one substitution example done with a lot of explanation with that one. The next one I'm going to do, I won't do quite as much explanation. Okay? So for this next one, find the point of intersection. I'm going to write out my two equations. So I have 2x minus y equals 4. My second equation, I have 4x plus y equals 9. I'm going to isolate a variable. When I'm choosing a variable to isolate, remember I'm going to choose one that has a coefficient of 1. I'm going to isolate this y right here. It's already positive. Actually, I'm going to do an example where I'll show you where you might make mistakes. So I'm going to isolate this y here. Okay. I have to isolate positive y. Y is negative on this side of the equation. Okay. So to make y positive, I'm going to move it to the other side of the equation. So I get 2x equals 4 plus y. Y is almost isolated. Okay. I'm just going to now move. I'm just now going to move the 4 to the other side to get y by itself. So I get 2x minus 4 equals y. Y is now isolated. Okay, it's by itself on one side of the equation. It's positive. I know y is equal to 2x minus 4. Okay, so now all I have to do, step number 2, substitute that expression into the other equation. Okay, so I isolated y in equation 1. That means I substitute what y is equal to into the second equation for y. So I know y is equal to 2x minus 4, so replace y with 2x minus 4 in the second equation. So sub y equals 2x minus 4 into equation 2. Okay, so 4x plus y is 2x minus 4. I put it in brackets. Okay, equals 9. In this scenario, it doesn't really matter that the brackets are there because we're just adding it, but it's good to get in the habit of that in case we are subtracting, to remember to apply the subtraction sign to each term inside the brackets, or if it had to be multiplied by a constant, we would have to use the distributive property. Okay, so I replaced y with 2x minus 4, left everything else the same. I now go ahead and solve. I can just drop the brackets because I'm adding. Okay, so really I'm just applying, there's a 1 in front there, I'm just multiplying those by 1 to get the brackets out. So 1 times 2x is 2x, 1 times negative 4 is negative 4. Collect my like terms with the same variable with the same exponent. Those are both x to the 1. I can collect those. I have 4x's and then 2x's. That gives me 6x. I'm now going to move that 4 to the other side, collect it with the 9. 9 plus 4 will give me 13. Well, I'm going to have fractions here. Divide the 6 to the other side. I get 13 over 6. Okay, so that's what x is equal to. X is equal to 13 over 6. That's where those two lines are going to intersect. They're going to intersect at 13 over 6. Okay, so just a little bit more than 2 on the x-axis they're going to intersect. Okay, now I have to figure out what the y value is where they intersect. Okay, I know they're going to have the exact same y value at 13 over 6 because that's where they're the same. That's where those two lines intersect. Okay, at 13 over 6 something. Okay, if I plug in 13 over 6 into either one of those original equations, 4x, change either of those x's to 13 over 6, I'll be able to solve for y, and it should give me the same answer no matter which one of these equations I plug it into. Okay, I'm going to plug it into the first one just because it's smaller numbers, it'll be easier to work with. So sub x equals 13 over 6 into the first equation. Okay, my first equation tells me that 2x minus y equals 4. So 2x minus y equals 4. I'm now going to replace x with 13 over 6 because I know that that is what x is equal to. That's where those two lines are going to intersect, and I'll be able to determine what the y value where they intersect is. Okay, 2 times 13 over 6 minus y equals 4. Okay, this is where we're going to have to remember some of our fraction laws. Okay, when we're multiplying fractions, just multiply the numerators and the denominators. So any whole number is over 1. So 2 over 1 times 13 over 6, just do 2 times 13, it's 26. And 1 times 6 is 6. So 26 over 6, which in lowest terms, 3 goes, or sorry, I can divide both those by 2. Okay, 3 doesn't go into 26. Well, 2 goes into 26 and 6, so divide those both by 2, I get 13 over 3. Okay, so lowest terms, that's 13 over 3 minus y equals 4. I know I'm going to want to solve for positive y eventually, so I'm going to move this y to the other side to make it positive. I'm going to move this 4 to this side so I can collect it with this constant over here. So minus 4, any whole number is over 1. The y is positive on the right side. Now I need to get a common denominator in order to subtract fractions. So if I multiply the top and the bottom and top of this fraction, so the denominator and numerator by 3, that'll give me a common denominator of 3, and I'll be able to subtract them. Okay, I have to remember to multiply the top by 3 as well. That way we're not changing the value of this fraction, we're keeping it the same. Okay, if I just multiplied the bottom to get a common denominator, it would change the whole value of this fraction, and then our answer is no longer valid. Okay, if we're going to multiply the bottom by 3, we also have to multiply the top by 3 to keep the ratio equivalent. Okay, so 13 over 3 minus 12 over 3 equals y. So 13, when we're subtracting fractions, we just subtract the numerators, leave the denominator the same. So 13 minus 12 is 1. We leave the denominator the same. Y is equal to 1/3. Okay, so I now have my y. Y is 1 over 3. I have my x-coordinate of the point of intersection. It's 13 over 6. So my point of intersection, don't forget to write your final answer. Point of intersection is 13 over 6, 1 over 3. Don't forget to write it as an x, y coordinate. Okay, don't forget the order. Okay, so there's my point of intersection. That's where the two lines intersect. At 13 over 6, 1 over 3. That's the coordinate of where those two lines will intersect. Okay, so this is actually 1 over 3. Okay, let's do one more example for good measure. Last example, I have 4x plus 2y equals 8. In my second equation, I have negative x minus y equals 6. Step 1, isolate a variable. I don't want to isolate either of these. I mean, I could in this instant. I'm not going to get fractions if I do. If I isolated this y, just because 2 goes into the 4 and the 8. But just to be safe, if you don't see that right away, just isolate a variable that has a coefficient of 1. So either this x or this y, they both have an invisible 1 in front. I'm going to choose to isolate this y. Okay? So remember, I need to isolate positive y, so I need to move this y to the right side to make it positive, because it's negative on the left. So I'll follow the same format we've been using. I'll draw an arrow here. I'm going to isolate it. Step number 1, that y. So I move the y to the right. And to get it by itself, I'm going to have to move that 6 to the left. So I'm going to bring that 6 over. It's going to become negative. And that y becomes positive moving to the other side. Okay, I've now isolated y. I know y is equal to negative x minus 6. Step number 2, substitute that expression into the second equation. So substitute negative x minus 6 into the other equation. So in this case, I isolated a variable in the second equation, so I'm now going to substitute that back into the first equation. So always into the other equation that you haven't used yet. Okay, so I isolated y in the second equation, plug in negative x minus 6 for y into the first equation. Okay, so always into the opposite equation of, okay, the one that you haven't used yet. That's very important right here. Okay, so not necessarily second equation, just into the one you haven't used, into the equation you haven't used, into the unused equation. Okay, glad we clarified that. Let's keep going. So sub y equals negative x minus 6 into equation 1. Okay, I isolated y in the second equation, plug in what y is equal to into the first equation in order to find the point of intersection. Ooh, that rating's terrible. That's okay. You heard me say it, you know what it says. Okay, so let's go ahead and do that. So 4x plus 2, I know y is equal to negative x minus 6. I'm going to put that in brackets so that I remember to distribute that 2 to both terms inside, equals 8. Okay, so I'm going to distribute that 2. Always do brackets first, okay? 4x, so 2 times negative x is negative 2x. 2 times negative 6 is negative 12. Okay, I'm going to collect all my like terms. These are like terms, 4x and 2x, they have the same exponent, or sorry, they have the same variable to the same exponent. They're both x to the 1s. I can collect them. 4x, take away 2 of those x's. I'm left with 2x. Move that 12 to the other side. 8 plus 12 is going to give me 20. Divide the 2 to the other side. I'm going to get x equals 20 divided by 2, which is 10. Next step, I know x is equal to 10. That's the x-coordinate of their point of intersection. Okay, point of intersection, everywhere the two lines intersect. Okay, I know the x-coordinate is 10. I need to now figure out what that y-coordinate is. So I'm going to substitute 10 into either of the two equations, either one, okay, for x. So either for there or for there, either one should give me the same answer because at 10 on the x-axis, so if this is 10 on the x-axis here, they both have the same y value because that's where they intersect, okay? They both have the exact same y value, okay? So I'm going to go ahead and plug it into either one. Let's get rid of all that stuff. Okay, I'm going to plug it into either one. Let's plug it into the second one just because they're smaller numbers. Once again, it'll be less work for us. So negative x minus y equals 6. So plug, so sub x equals 10 into equation 2. Let's plug it into there. So negative x minus y equals 6. Is that what it is? Let's check. Equals 6. Good. So plug in 10 for x. So negative 10. Replace x with 10. Leave the rest the same. Collect my like terms. I'm going to move the y to the other side so it becomes positive because I know I need to solve for positive y. Okay. I'm going to also move the 6 to the other side to get y by itself. So the 6 is going to become negative. The y becomes positive on the other side. Negative 10 minus 6 gives me negative 16. I now have my point of intersection. I know the y-coordinate of the point of intersection. I know the x-coordinate. So my point of intersection is at 10, negative 16. POI is at 10, negative 16. So once again, the steps I did, I isolated a variable. I isolated the y in the second equation. I then substituted what y was equal to into the other equation, so into the first one. So I substituted that expression into the unused equation. I substituted it in, subbed it in. I then combined all my like terms. I remembered my order of operations, and then I solved for the variable. I solved for x. I then substituted that value, x equals 10, into one of the original equations, either one. I chose to use the second one because it looked like it would be less work. And then I solved for that second variable. And I could then write my point of intersection because I had the value of both the x and y coordinates. Okay, so that's it for substitution. That's all I'll show you. You should be well prepared to use substitution to help you find points of intersection now. Any questions? Visit jensenmath.ca. Or watch this video again. Try the worksheets. Have a good day.